The maze of transmission lines are the conductive paths that signals use to travel between chips and to the outside world. In this cross-section of a circuit board, we see these transmission lines are routed through several different layers using channels called vias. The material surrounding the transmission lines and the line's dimensions contribute to capacitance, resistance, and inductance, which affect the signal's performance. As with chip design, computer-aided design programs facilitate line geometry and routing, as well as the layout testing of printed circuit boards. These designs go on to be fabricated into the actual boards, which will hold various electronic parts. The bare printed circuit boards are loaded onto the assembly line. The boards are aligned by verifying known patterns with a video camera. In screen printing, solder in the form of paste presses onto the board through a brass stencil. Pick-and-place machines automatically inspect each electrical component before placing it where the solder paste was deposited. This is known as surface mount technology. Because of the various sizes and assembly requirements of the components, several different machines are used. Now the boards go through an infrared oven. The solder melts or reflows, binding the components to the top side of the board. Surface mount technology allows electronic components to be mounted on both sides of the board. This twin station temporarily glues tiny devices to the bottom of the board until they can be soldered later in the process. The circuit board is again subjected to infrared reflow to harden the glue and then flips back to the top side. The other way of placing parts on the board is the through-hole assembly process. Here, electronic components with wire leads are inserted through holes in the circuit board. The robot arm picks up multiple parts at one time. These parts are held in specially designed feeder mechanisms. Small components like these speaker connectors automatically present themselves to the robot arm for insertion. The wires that go through holes in the circuit boards are clinched from underneath to hold them in place until they are soldered. This eyelet setter, or rivet press, secures any large connectors located at the edge of the board which need extra strength. The circuit board now contains all of its components. An operator makes a final visual check. A wave solder machine does the final soldering. The bottom of the board is first coated with solder flux. This substance cleans the leads so the solder may adhere correctly. Bubbly solder preheats the boards before they encounter hot flowing solder. This secures all the leads and any components attached to the bottom of the board. It also fills any vias or other exposed holes in the circuit board. From beneath, we see the hot solder just touches the wire leads. The boards go on to be washed to remove contaminants and any remaining flux before they are electrically tested. Once they have passed their test, they move on to system assembly. The boards are placed in a computer casing. The speaker assembly and the data cables for the disk drive are then installed. The disk drive mounting bracket, along with the floppy drive, are inserted. The hard drive snaps into place and the drive power and data cables are attached. The power supply for the computer is installed, and the system is fired up to prepare it for the first phase of testing. Additional temporary memory and test cards are installed that allow software to exercise all areas of the system. An operator monitors the testing and verifies that the system is running correctly. The test cards are removed and the assembly of a personal computer is complete. What allows hardware like these machines to perform various useful operations is the flexibility of software. Software consists of many layers of programs.